Solving problems using measures of central tendency. Measures of central tendency, by the way, it's just averages, like mean, median, and mode. Those are measures of central tendency. Measures of the middle. Central tendency just means the middle. So sounds real fancy, but they're just mean, median, and mode. So let's get on with it. All right, the amount of electricity in kilowatt hours, that's what kWh is, kilowatt hours, used by one household each month of a year is listed below. So we got 12 different data points here for each of the 12 months. And we're being asked to make a line plot of the data. Okay, line plots, great way to organize data. Very quick, very easy. First thing I'm going to do is kind of look at my range. Looks like the smallest number is 420 and the biggest number is 590. So let's make a line here that goes from 400 to 600. I'm going to scale it by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90, 500. And then we'll put 9 dashes, and the 10th one will be 600. And here's how you make a line plot. 420 and 450. And we just put those two pieces of data on our line plot with an X. And we'll go right down the row. 480 and 440. Here's 480 right here. And here's 440 right there. 420 and 490. Okay, now 420, it's the second time 420's occurred. So what we do is stack those up on top of each other. And we have to be careful. We want to make every X the same size. I'll tell you why in a second. 580 and 590. There's 580, 590, 510, and 450. 510, 450. Put that one on top. 430 and 480. 430 is right here. 480, we'll put that one on top. And we're done. Okay, so here's a line plot. And the reason we want to make all our x's the same size is it kind of looks like a bar graph when you're all done. You can see which numbers occurred the most. Okay, 430, 50, 470, I'm sorry, 80, 20, I'm sorry, 10, 420, 30, 40, 450, and 480 occurred most often. Okay. And we can also see how spread out our data and where there's gaps in our data. Really quick, really easy way to organize data. I could do this with your test scores for all of my classes and see kind of how the data was spread out. Make decisions on my teaching based on that. Okay, so find the mean, median, mode, and range of the data. So let's look at that data again. Mean, median, mode, and range. Well, the mean is the sum of all the numbers divided by how many there are. So if we add up all these numbers, I'll do it for you. We get 5,310. There's 12 pieces of data, 12 months in a year, which means the mean is 442.5. That's a measure of central tendency, and that's kilowatt hours, by the way. So 442.5, 10, 20, 30, 40. So that's right about here. Okay. Our median is just the middle number. Now, usually we have to put the data in order to determine the median. We've already done that. 420, 420, 430, 440, 450, 450, 480, 480, 490, 510, 580, 590. All these numbers are in order. So all we have to do is find the middle one. The middle one is actually the 6th and the 7th one. I'm actually just rewriting these numbers because I know that they're already in order over here, doing what I just told you we could easily do. So the middle numbers are actually the 450 and the 480. So what we're going to do is add those up and divide by 2 to find what's halfway between them. Not sure I really need to actually add them up and divide by 2. I know that halfway between 450 and 480 is 465, but it does work out right. Okay, and then lastly, the mode is very easy to determine once we've done a line plot because it's just whichever x's reach the highest. And I already said those, 420, 480, I'm sorry, 420, 450, and 480. I should have scaled this more, probably. So those are all the mode. That's kilowatt hours, by the way. Okay, which measure would we use to report? I'm sorry, which measure would you report to describe the difference between the most electricity used in a month and the least? Okay, well, we'd use the range. Which is the biggest number minus the smallest number. So there's a difference of 170 kilowatt hours between the most used in a month and the least used in a month. We were actually asked to find the range on example B, by the way, and we didn't do it. But now we have. So there's the range. Which measure would you report to someone who wanted to compute the total amount of electricity used in a year? Well, I'd tell them the mean. Why would I tell them the mean? The mean isn't the total amount of electricity used. It's the average amount of electricity used each month. But someone who wanted to know the total amount of electricity used each month could just take the mean and multiply it by 12. And then they'd know how much. We divided the total sum by 12 to get the mean. So in reverse, we could take the mean and multiply it by 12 to get the sum of all the electricity used in every month. If the greatest data point, 590, were changed to 500, which measure of central tendency, mean, median, or mode, would change the most? That's an interesting question, and we really have to think about that a little bit. All right, well, the mean would actually change the most. The mean would change the most. We go through this item by item. Why? The median and mode, the median and mode wouldn't change at all. In this particular case. Sometimes they would if you changed a number like the greatest data point, but in this case they wouldn't change at all. Let me go back here to this page and show you why. Okay, the mean was 442.5. So if we take the biggest data point, 590, and we're going to be taking away from the sum, which is obviously going to make the mean less. But if we change this 590 to a 500, it's still bigger than the median. This 590 would still be right here. The median wouldn't change at all. The middle numbers would still be 450 and 480. And also, if we change the biggest number, sorry, where's my, there it is, to from 590 to 500, well, we don't have any other 500s. So it's not going to make it in one of the modes. So the mode's not going to change at all either. It's still going to be 420, 450, and 480. So in this case, the mean is the only thing that would change at all. Sometimes the others would change. And you know, if we took 590 and we made it something less than the median, something less than 465, then yeah, that's absolutely going to change our median. Make a list of data values that fits the statement. Half of the days of February were colder than 30 degrees Fahrenheit. Find the mean, median, mode, and range of the data. Well, we could all create different sets of data that satisfy this list, that satisfy the statement. Half the days of February were colder than 30 degrees Fahrenheit. You do need to know one thing. There's 28 days in February, at least on non-leap years. So here we go. I'm going to make a list of data values. There's 14 days that are colder than 30 degrees Fahrenheit. And here's another 14 days that are not colder than 30 degrees Fahrenheit. So this fits the statement that half the days of February were colder than 30 degrees Fahrenheit. Pretty lazy list, but it'll work. Now let's complete the mean, median, and mode. The mean would be 32 times 14 days. And we're going to divide that by 28 days. It's 32 plus itself, 13 more times. It's 448 divided by 28. I don't know why I'm doing all this work. Obviously, the mean is going to be 16 degrees Fahrenheit. If I got half my data points are 0 and half are 32, the mean is going to be 16. The median is going to be halfway between this 0 right here and this 0, or this 32. So 0 plus 32 divided by 2 is, again, 16 degrees Fahrenheit. And the mode would be the number that occurs most often. In this case, it's 0 degrees Fahrenheit and 32 degrees Fahrenheit. And the range is the biggest number minus the smallest number. So it's going to be 32 minus 0, or 32 degrees Fahrenheit is the range, the variability of the data. Now, if I change even one of these numbers, my list would still be accurate for this statement. I could change this 0 to a 1. Half the days would still be less than or colder than 30 degrees Fahrenheit. I could change any of these 32s to something greater than 30, and I'd be fine too. I could go into negatives. I could change all of them. There's an infinite number of ways we can arrange this, literally. But this is just one way, so I took the easy route. All right, that's all I've got for today on mean, median, mode, and range, and some problem solving using those measures of central tendency. We'll see you soon.